talk to your mother on the phone, you can drive the car, and maybe kiss your girlfriend at the same time. Yes, I had one classmate who was, while taking a shower, he was reading his textbook in a plastic cover. He will never lose any time. He was always multitasking. But guys, you know, here is mathematics. So mathematics and multitasking don't go together very well. Do you understand me, eh, guys? You understand me? Yes. You can kiss your girlfriend, talk to your mom, drive a car. That's okay with me. But here, if you want to learn high quality, and maybe do something more. Number 4. What should be number 4? Write your homework in calculus class. Or you can dictate to your girlfriend to write your homework. Something like that. Okay, guys. So here the idea is again, if we can get rid, at least temporarily, from this e to the power of x. We don't like e to the power of x. Can we get rid of that? So, e to the power of 2x minus 3. Now let's substitute here u minus 4. But what should we do here? Not so difficult, because e to the power of x, and we can raise to the power of 2, so now it becomes u squared minus 3u minus 4 equals 0. We solve this equation for you, and then go back and solve it for e to the power of x. What do we get here? What are the solutions, guys? U squared minus 4u plus u minus 4. So we get u minus 4 plus u minus 4. So this becomes u minus 4, u plus 1 equals 0. So the roots are 4 and minus 1. Minus 1. Now, one of the roots we can immediately discard. Which one? The minus one. Why? Because e to any power, we can raise e to any power, but we can never come to minus 1. The result can never be negative. So minus 1 we discard. So we get only 4. And what do we have? E to the power of x equals 4. Now, how much is x? How much is x? Again, we have to use the power of the inverse function. We take logarithm of the left-hand side equals to logarithm of the right-hand side. This is possible because both logarithm and exponential functions, they are 1-to-1. 1-to-1. Because they are 1-to-1, when we take logarithm from here and from here, we don't lose any solutions. We get exactly the same set. Logarithm exponential, we get x, and here logarithm of 4. How much is logarithm of 4? 1 point something. 1 point something. Okay. So, logarithm of 4, it's a complicated number. And not only it's complicated, but we cannot get the exact solution. We can only get approximation of the solution. Who wants to try this without looking into the slides in the future? we don't have an exponential function. No, we have an exponential function, but we don't have this famous function e. So what should we do? And we have different bases, 4 and 2. First delete the board. Where is that guy? Some people say, I'm not good at calculus, and they don't come to class. Okay. And now, 4. We can represent 4 as what? 2 to the power of 2. That's an idea. And then we will get the same base. The same base. Yes. 2 to the power of 2. Okay. It's not plus 1, it's plus 2. It's because 2 to the power of 2 raised to the power of x plus 1, yes, minus 2 to the power of x plus 2 minus 3 equal 0. Now guys, can we get rid of 2 to the power of x now? That's the first goal. We want to simplify a little. How can we simplify? How can we simplify? For example, 2 to the power of x plus 2, we can represent 2 to the power of x multiplied by 2 to the power of 2. And now this is just a constant. We can forget about it. Here, 2 to the power of 2x multiplied by 2 to the power of 2. And then here we can 2 to the power of x raised to the power of 2. And we can get rid of 2 to the power of x. We can call it u, and then from here we work. Right.
Why?
You want to help? Come. We want to, yes. Right, but it's not like that. It's not like that. Multiply by 2 to the power of 2. Right? See the arithmetic. Your problem is with arithmetic. Multiply by 2 to the power of 2. Now, plus this one minus 3 equals 0. So now here what do? We take 2 to the power of x to be u. Now what equation are we going to get? U squared. Very good. Multiplied by 4. Where 2 to the power of 2 is what? 4. So let's put it here. I think the sign is minus. Here is minus, yes. Alright, but here again is minus 4. So somehow you lose the constant. Can you solve this equation? 4u squared minus 4u minus 3 equals to 0. Okay, sit down. It's not so bad, man, but you have to practice algebra. So, we're going to skip solving the equation because it's from high school mathematics. We are not going to deal with it. So we have two roots. One is 3 over 2 and the other one is minus 1 over Now, minus 1 over 2 what? Can it be minus 1 over 2? 2 to the power of x, can it become minus 1 over 2? No. The range of 2 to the power of x is from 0 to plus infinity, the range, the possible values. So we discard it. And we have only this. 2 to which power gives us 3 over 2. Here we throw away that's not possible. And here again the same trick, guys, the same trick. We cannot work with 2 to the power of x, so we take the opposite function. But you have to be careful here. The most convenient opposite function is what? 2 to the power of x, the opposite is the inverse. The inverse is logarithm base 2. So logarithm base 2 and 2 to the power of x, they cancel. So here we get x equals logarithm base 2 of 3 over 2. Okay. Now, here what is that? Here, maybe on our calculator there is no logarithm base 2. If there is no logarithm base 2, we can convert to natural logarithm. How? We take natural logarithm of this and we take natural logarithm of the base. And this expression always equals that expression. Here approximately. Why approximately? Can you like imagine why it's always approximate here? It's never exact. And we are done today. Yay. Wait, guys. We have to answer that question. Why it's approximate?
Because it's never ending number.
Huh?
Yeah.
Why it's never ending number? Remember, all these functions, logarithm, guys, let's finish with that. That might be from the final exam. Now, I'm getting angry. Listen, guys, do you remember the two important slides, the theoretical slides? How do we compute logarithmic functions? By using infinite sum and we cut it somewhere. Now, when you cut the infinite sum, you always get the approximate result. You never get the exact result. So, logarithm of very few numbers is precise number. Always here is an approximate number because we have infinite sum and we cut it somewhere. Any questions? Okay, guys. Next time we start with the derivatives. What I want is you to understand what derivative is. It's based on the limit. Very simple, based on limit. So this is your reading assignment. Maybe there will be also another assignment. I will tell you if I'm going to Bangkok. So if I'm going to Bangkok, you just work on the homework. You don't come to class. But you have to read the announcement. See you guys. Bye-bye. Yes. Bye.